When we're using intensity to quantify the amount of energy in a wave, we come up with a huge range of possible intensities. This goes for sound waves and many other types of waves as well. As you've seen in the book, the quietest sound that can be heard by human ears that are functioning about as well as human ears could function is tiny number, 10 to the minus 12 watts per square meter. The high intensity that would be dangerously high intensity for human ears, 1 watt per square meter. So the dangerous intensity is a factor of 10 to the 12th bigger than the quietest intensity, a factor of 1,000 billion, a huge range. And so we need another kind of scale for describing the energy carried by the wave, and we use so-called intensity levels, distinct from intensity. Intensity levels measured in decibels rather than watts per square meter. And the rule for converting between intensities in watts per square meter and intensity level in decibels is this rule right here. Right? The number of decibels, beta represents the number of decibels, equals 10 deci. The prefix deci means 10. 10 times the logarithm of this ratio. The intensity that we're interested in divided by some kind of baseline intensity, and the baseline intensity is simply the quietest intensity that a normal human ear could hear. So to understand this conversion between decibels and watts per square meter, obviously we have to understand what's going on with logarithms. So a review of some old stuff that some old mathematical stuff that you probably haven't thought about for a while. The important thing to remember is that a logarithm is an exponent. Repeat that to yourself enough so that any time you see a logarithm, the first thing you think is that a logarithm is an exponent. So a little more detail, what kind of an exponent? Well, imagine that you're taking the log of some number, log of x. Well, this being a log, it's an exponent, and then we give the name y to that exponent. In particular, the log of some number, it's an exponent. Specifically, it's the power to which we raise 10. Whenever we say log, we're talking about powers of 10. And specifically, the log of x, which we call y, is the power to which you raise 10 in order to get x. Right? This statement and this statement imply each other. They are equivalent statements. Together, you can think of them as a definition of this logarithm. Logarithm is an exponent, and in particular, what kind of exponent? It's a power to the base 10. So let's see how that actually works in practice when converting specific values of intensity into a specific number of decibels. And let's start with just the quietest intensity that humans could hear.
Okay.
All right.
Let's see. We need to find